Now, as we move on to tables, they're all going to be done the same way. We're not going to look for anything too fancy. So we're going to look for the y-intercept first. That's when x equals 0 in your table. So we're going to look down the x column. Here's when x is 0. So that would be your y-intercept. So A would be 0, 0. Your roots. Your roots is when y equals 0 in your table. So we just look at the y's. This would mean our first root was x equals -4 because x is -4 there. Well, here's another one. That means we have x equals 0. We have another one here when x equals 2. Okay, a relative maximum is if we're increasing and then it changes to decreasing. So how do we know that? We're going to take a look at our values. So we're going to look over here at y, and we're just going to, I put like this little squiggly thing here. This is increasing, 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 increasing. Still increasing, increasing. So all of these are increasing because the numbers are getting bigger. But then right here, between 16 and 9, that's a decrease. So what that means is somewhere in here, it changes directions. So it's like it was increasing, 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 and then decreased. So that means that this would be your absolute maximum. If we knew the point exactly, then there would be symmetry in the table. But we don't know the point exactly. So we're going to say that it is between the numbers -2 and -1. So we're decreasing. And then from 9 to 0, we're still decreasing. We're decreasing. We're decreasing. But from -5 to 0, that's an increase. So if we're decreasing, 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 and then we increase, that would mean there is a minimum point in there. So for choice D, we would have a minimum point between 1 and 2. If we keep following the pattern, from -5 to 0 was an increase. From 0 to 21 is an increase. And then increase, 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 increase. So there would be no other extrema listed. Okay, let's take a look at number 2. Let's try and find our roots and our y-intercept first. So our y-intercept is when x is 0. So for A, right here, y equals 2. To find our roots, we're looking for when there is a y equals 0 in the table. I don't see that. So one way you can find the roots is when there's a sign change. You won't know the exact number, but you can give the x values that it would be between. So like if the number above is a negative and then it becomes a positive, or the number above is a positive, and then it becomes a negative. So negative, 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 positive. So right here, there would be a root in between those two x values. So our roots would be between -2 and -1. And then look for a change again. Negative, positive, positive, negative. There would be a root in between here too. So 0 and 1. I'm going to keep this consistent and not circle these y values. And then we're going to go positive, negative. And then this changes back to positive. So there's another one here between 1 and 2. So negative to positive, and then there's no more. Looking at part C, it wants a relative maximum. So a maximum point would be if we were increasing and then decreasing. So let's check our pattern here. Negative, but this is increasing, 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 increasing. And then from 2 to -2 is a decrease. So that means right in here, between 0 and 1, would be a relative maximum. So now, let's see if we got any others. So if it's decreasing, decreasing, and then this increases. So if it's decreasing and then increasing, that means that we just found a relative minimum between 1 and 2. And then I think that's it. 24, increase, increase. The rest just keep on increasing. So this is why, if you notice, I'm using a lot of colors, because this makes the most sense to me. Okay, let's take a look at number 3. Your y-intercept is when x is 0. So it would be the point 0, -4, or y equals -4. To find our roots, we would look for when y is 0 in the table. You don't have a distinct one of those. So if you can't find it, you're going to want to look for a sign change. So if it goes from positive to negative or negative to positive, all positives, these change signs, which means in between here, there would be, right between -1 and 0, there would be a root. Negative, 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 negative. They all stay negative, so there'll only be one root. So what that means is we're starting way up here at almost 5,000, and then we're just going down and 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 down. So there shouldn't be a relative maximum because these numbers just keep decreasing. That also means that there is not a relative minimum, again, because they just keep going down and down and down, and they would just get smaller and smaller and smaller and go towards negative infinity. Okay, let's take a look at number 4. We're looking for our y-intercept first, right here at 0, -1. Now let's find our roots. Our roots is when y equals 0 in the table, or if there is a sign change. Don't see 0, so now we're going to have to look for a sign change. All negatives. This goes negative to positive, so that means there's going to be a root in there somewhere. Parts, gotta finish that again. So then negative to positive, the rest are still positive, so there's only one. So we're starting down here at -10, if you visualize it, way down here at -2,000, and it just keeps going up, which means there will not be a relative maximum and a relative minimum. How can you look at that further? increase, 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 increase. These just continue to increase. There's not a change in increase or decrease. And then lastly, number 5, the y-intercept is when x is 0 in the table. Here you go. We're look for roots. So when y is 0 in the table, or if there is a sign change, oh, here's a 0. So that would be when x is 0. Here's a 0. So when x equals 5. One here when x equals 7. We're now going to look for our relative maximums. So a maximum is if we were increasing and then decreasing. So this is increasing, 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 increasing. These are all increasing until we get to here. Here. Because between 30 and 24, it would decrease. So there would be a relative maximum somewhere between 2 and 3. And then this is decreasing, 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 decreasing. And then this increases. So if we're decreasing and then increasing, that means we have a relative minimum somewhere in between here of up in here. Sorry, because from -6 to 0 is an increase. So this would be 6 and 7.